Thanks for joining. So we are ready to go. So chapter 1, lesson 1, overview of infrastructure design. So you have seen the syllabus. Down into the description you'll find the slides that you see here. So no reason for any kind of note. You'll have everything. But let's start. So we do know that there are two words that are connected to each other, the IT and the OT kind of word. They all run based on some architecture principle and common practice on designing. So if you go, obviously the IT model was applied to the OT model and even the reverse as well. There is a lot of conversation on OT right now, moving from SCADA and having more IoT. If, for example, the classical way of designing through a Purdue enterprise reference architecture framework is still relevant, but that is still one of the pillar. In this course, I'm not going to focus on the OT part. I focus on the IT part. So I haven't been exposed enough to OT to be so knowledgeable about it, but it was worth a mention because actually the two words are interacting to each other. And as I said, the IoT and a lot of the deployment of sensor and everything is going to be more and more melting the two. So the typical kind of deployment in IT is based on a sort of onion design where you are having the core layer with across the distribution that is serving the access layers. That is a key point in most of the design. When it was designed, it wasn't. It was designed to be more focused on on a layered approach that with the time and the maturity is going to disappear. You are having a conceptual design where each area is supposed to be compromised. And so you concept of a layer is still extremely valuable because it is the layer that allow to do microsegmentation, zero trust access, and whatever. But you'll see whatever design, cloud, no cloud, is still based on this key core point. So when you are designing in an infrastructure, you'll try to adopt a logic on how you read whatever you have in front. So I will zoom in the complexity of this problem. But whenever you are looking at a diagram, the first suggestion is to identify what is core, what is distribution, and what is access layer, because it will give you an overview of how an attacker can move across the environment as well. There is a problem that is extremely practical on the fact that there is no standard for diagrams. So if you are an IT security consultant, you'll find kind of problems because everybody will give you a different type of diagram. The logical about branch, the topology, the basic network that is actually extremely irrelevant most of the time, a network diagram that is zooming in at layer 2 with all VLAN, trunk, and all other stuff, but sometimes it's missing what is running on top or is missing the automation layer. The NFV, for example, deployment of SDN kind of orchestration. And cloud diagrams are starting to get more and more popular in terms of logical. It's generally really good, the cloud, because you find quite easy translation into a threat model because you are having some structure that are going across all layer or layers, And so compared to before where you could have diagram only at layer 3, layer 4, right now in the cloud, generally you see the entire stack. It's true that the network is moving at layer 7, and so it doesn't make much sense right now to have this distinguish as before, because actually the VPC is controlled by an API. You can change whatever through an API, and so whatever attack, you need to consider also the underneath layer. One of the problems that I experience with network diagram, cloud diagram in general, is the fact that sometimes you miss the overview of what before was quite easy to understand as a management access. And so you see the components, you don't figure out quite well how they access to. And so the problem is that there are some approaches that can be different because actually some can use the console, some is still based on Bastion host, as it's called, the Java box, doesn't matter. And so some of the diagram are not updated or not reflecting the full picture, or also the management. Another problem is that whatever you see on that diagram, it doesn't tell you what create that. So in cloud is quite relevant if you talk about Terraform, for example. Is if you take a Terraform open source version, doesn't have a Vault integration. So for example, having an understanding of that layer, and it's something that I will stress in this course, is quite important because with experience, some small detail can tell you already some problem. Because, for example, if Terraform doesn't have a vault, it means that those secrets are into the playbook. There is no rotation. You can already guess a portion of the issue there. So, but it's not finished because every professional in IT does have his own way of doing diagram. The complexity, for example, on storage is high, and iSCSI kind. So you'll find diagram that is really focus on something, database, tables, and everything. So be ready because you'll not find the standard. You'll find that most of these one are anyway based on the knowledge also of who wrote it. So if you can find documentation extremely strong on one layer instead than the other one because actually who did it was more knowledgeable. Automation of documentation in cloud should be quite easy and straightforward, but it's not always the case. I still see struggle to envision high-level design where, for example, API are well explained in the complexity, gateway management of a gateway and all other things. So with experience, you'll understand way more what I'm saying, but just an heads up, it will drive you nuts. Each, especially if you're in consulting, each customer will have something different. You could find that you don't have absolutely nothing as well. And so as something to put into the picture, what I generally do is thinking in blocks terms. So the next slide, I will give you some tips and tricks on how logically think about the components and how they talk to each other. So when you are going in a corporation that is a global, worldwide, obviously each diagram can zoom in uh, so much, but you are missing something. So you need also to have the understanding on how to do it on your own and see that. So let's drive forward the conversation and I give you some tips. But first of all, let's focus on why we design in a certain manner. So in this slide, you have a sum up of a well-architected framework. So AWS started, Azure and GCP followed up. You see the reason are always the same. The pillar are in somehow around the same. The on-prem because it's not the reliability wasn't important in on-prem. You had for sure a cost problem that wasn't there due to the licensing, and so it's for sure more specific to cloud. Uh, the way of how do redundancy, reliability engineering in cloud is different than on-prem for sure, and so the complexity is at a higher level. You have zones, you need to look into redundancy with a completely different approach than on-prem. But the pillar, if you see across the vendors, the quite similar. So when you specialize in talking with a customer, everybody will push the conversation on the direction that they want. They feel confident, you are having a chat, is explaining the architecture, they will push in their terminology, in their way to talk, and obviously a good consultant does know with all dictionary that he can, is following and listening, but he needs to drive a bit also the conversation. So even a simple concept like phishing can be seen from the attacker and from the company perspective. But for you, from an infrastructure perspective, are all service dependency. The fact that when an endpoint is connecting, it can use an access point that is compromised. The access point can serve the DHCP and can be compromised. There are a plethora of dependency. So the endpoint itself is not independent. You'll have a trust model that at a certain stage will be gone because it's the same than the BIOS. You can have OS security, but later on have a problem like we saw it with Intel and move a layer lower. So let's face trust is just a boundary that you move, and there is always some portion of trust. Some portion of trust that you can be only with a vendor that gave you the software. You can have vanilla images, but you haven't done the code review. And so also that is trust. When you are talking in an interview with a customer, you should drive a conversation trying to answer the questions that are needed for you to understand the exposure. So if somebody describes a phishing attack, can be the most basic, but is going through some pillar that you can suppose. A spoofed email address. On the other end, you have a SaaS service. You have a malicious link, an include, an attachment. You can have another overlay layer where it's clicking. You can be even triggered by a JavaScript because at the end the client is actually browser if it's HTML, is executing a payload, can do cross refugee attack basing on session hijacking, can try to reverse the connection, try to get that endpoint to connect out, trying to hook it to a command center, have persistent, and probably didn't tell you nothing that you didn't know so far. But as you see, you can structure the conversation on both directions, but it needs to be enough to answer your question. So if you go to a SaaS service, one of the logical questions is how does it happen that kind of connection? Is going through a CASB? Do you have a SaaS integrated approach to the connectivity in terms of is bring your own device? All that kind of question. So those are questions that you not find immediately if you focus just on the phishing attack. You need to think about the component, and the component will tell you which question to ask. For example, there is a proxy. Do you use VPN? Do you have a split tunnel? because actually it's changing a lot of the picture. If there is a split tunneling at the same time connected the company plus the private link, you need to think also in terms of race condition with the DNS. So you need to structure the conversation, think about the component, and based on that, think about the attack. That is the reason why you should have confidence to jump from attacking to defense, because switching the two is what gives you the flexibility. And adding the skills of infrastructure, the one that we are discussing here, you are going to complete this topic altogether. So, in summary, if I need to analyze what is the general rules in terms, you have always a dependency, as I said, from whatever component within the network, the DNS, the DHCP. You do have tons at all layers. Authenticate the user and devices. I see a lot of confusion across the two. If you authenticate the device through certificates, you need to compensate also to know if he is the user that he does have that. Don't forget a rule in forensics. If somebody during a forensics investigation find a credential used, he can never state that the credential user was having access. He will state in the report that there is evidence that the credential used was the one assigned to, because you can't imply that that was that user. Think about the golden ticket and all other attacks. So you need to be 100% sure that you don't fall into the common issue that you see when people talk about security. You need to think also with that forensic smartness and actually uh, understand if a device was authorized and the user authenticate, if there is a session hijacking, there is enough control to avoid it, to be sure that somebody is not actually hijacking a session. I put some example in there, for example, about isolate browser session is a functionality in Chrome to do it. There is a lot of conversation about remote browser isolation, that is your browser is going to query another remote browser, so to be sure that it is not exposed. But in summary, the rule is always not allowing direct connectivity back. And some jump on the chair and say, "Oh no, proxy, no, stop proxy." Okay, but command center are actually using reverse shell. We are day by day evaluating attack surface from outside to inside, but we get exploited due to the inside getting out. And so reverse your logic, don't fall into the trap that many professionals fall in. And so try to think out of the box also from a pen testing perspective. Attacker, pen testing, doesn't matter, I use it interchangeably. But think also on which kind of lateral move opportunity is given. When you do analyze endpoint, don't forget some microsegmentation consideration. Race time condition are my favorite. For example, most of the ADR solution works because they are online. What is happening if it's not online? So far, we rely on a lot of stack that was actually loaded in endpoint. Right now, most suppose an online continuous chattering by API for cloud sandboxing and all other kind of stuff. So what is happening if there is that time or race condition? Don't forget the best exfiltration that I actually consider a wake-up call for the entire industry is, for example, JavaScript. Runs everywhere, get access to DOM, can intercept the do keylogger. Check it out, magic card kind of example. Internal threat is another difficult consideration that any security professional is having a headache with and some trouble to make it. But you need to put it in the picture too. So don't make the mistake when you are analyzing the scenario that I showed you before to think that it can't be an internal threat as well to send the mail. Can be also the attacker to fake, but you understood what I mean. Depends on what you are thinking about. But don't trust supply chain include also security stack. So think about all these agents. They have a privileged access. API call are really, really important. And right now you need to think about it. So try to consider also the exploitation of your security control. I do recall if well-known log parsing visibility kind of tool that was suffering cross-site scripting due to an HTTP referring the log. Sometimes simple things works. You could have access if there was a callback outside for somehow to make it to actually exploit a SOC. So keep in mind that. So now we start with what I will draw on my notes as a consultant. So you'll get tons of documentation during the conversation with zoom in and zoom out, but you need to envision the components. So even if sounds ridiculous, because it's not a diagram, it's nothing else than a logical representation, but give you a lot of information because I use squares or whatever geometric shape you fancy across the on-prem because it's give me the lateral move kind. For example, on-prem can talk with Azure via an express route, express link, whatever is, you should consider that. VPN as well, whatever overlap and how is connected. What is the favorite access? Because that gives you an overview of how pollution and lateral move can happen and how probably some orchestration layer talk. So attacking the orchestration layer give you a lot and generally use anyway connectivity. So this one is the point that I'm stressing. And in my experience, this one sounds the most ridiculous, but it is the one that later on you keep in front of you for the project and together with all network diagram, database diagram, whatever diagram you need to swallow and digest will keep the big picture. So trying to add this one all the time to whatever project and do it yourself. Don't ask somebody else to do it. Draw it during the interview based on your answer a question. So you ask, you analyze a conversation, a scenario, you analyze the controls, and you double check all the time if this one is still relevant. And keep it simple. You don't have to redraw the entire network diagram into that. Just keep the summary of the project. I had a big jump in my career when I started to use mind mapping, and I'm surprised on why it's not so adopted across. So mind mapping, you can use it with versioning. You can have it wherever, even in Visual, whatever, Draw.io, whatever you fancy. A mind map is the easiest one. And whenever you go in a meeting, you do a new versioning of your mind map. If something was decided, you can write the notes on that and change. And you'll see in one shot how your mind map changed across a timeline. And that is the way how I spot that something is derailing during a project. I know I will offend whatever project manager is having the agile vision of the project, but this one is the way how I do to keep on check that high-level design in translation to solutioning, even if it's not done by me. Sometimes you get an high-level design that is given and you are the engineer and need to translate it, and somehow you need to be 100% sure that it's matching. How many times you take documentation and is actually completely different than whatever is implemented. And so keep in mind this one, use mind map more than you can, use this method as well, try. If it doesn't work for your way of thinking, trash it to the bin, do post-it, do whatever. It's whatever works for you. I just give you an understanding of how you could summarize even 20 PowerPoint in just one mind map. And that is actually how I work because I have a visual memory. And so, but when you understood the blocks, you need to put it in perspective of direction. And so, northbound, southbound, east, west, you need to understand how it works. If an MPLS is carried through an SD1, is actually a completely different design than two trusted domain from the bottom, completely isolated. So you need to always to put in perspective because each attack is unique for that. For example, a DDoS attack can be performed everywhere, but there is a completely different scoring also based on where you are talking about. It's difficult to talk about DDoS just without specifying if layer 3, layer 4, or layer 7, but you understood what I mean. A problem with an ARP spoofing, that is probably a better example, is quite complicated to do remotely sometimes, but it's not if you get a console. And so it's the reason why all this management conversation that I made before is quite important. I am, it's the core of everything. I We talk about zero trust, and sometimes you find I am at the very bottom because it's just a provider. No, it's not just a provider. It's just the way how actually they compromise your environment. Because if you have an hybrid AD, most of the time you risk also lateral move. And so you need to put in perspective IAM, but not just only for the IAM, but going through all step authentication, authorization, all part of a SAM, single sign-on, that is critical. You need to understand if they are in the middle of a migration. Whenever you check some project, some use something, and something use something else. You need to be 100% sure of the consistency, have an opinion, but don't forget the third A, accountability. It's logs cost. And you'll understand when you are a consultant that some conversations are not technical, are business cost wise. You need to understand not just the requirement for the log, what they contain, which picture they give you, can you index it, can you be sure that in somehow you can reconstruct and enrich the data crossing with something else. You need to think about accountability. But you need to think in accountability terms also on how the attacker can manipulate those. I do recall, and this is a common structure on all SIM, I'm trying to stay vendor independent, but whatever SIM structure you saw in the last years, it was using buffering. If you get buffering, you have that famous race time condition that I always talk about. Race time condition. What is happening if in the meantime something else happens? You need to think about it. And you need to think if your ADR goes in offline mode, can be exploited in the meantime and you don't see it from the console. That is an interesting point. Is potentially the browser exploitation in JavaScript something that you can see? Not often. And let's be honest, all payload that you see obfuscated on command center kind of connection, we pass through whatever you use, and there are a lot of bypass. So all these conversations are important because even all these logs can give you an help in understanding what happened. So right now we go for a nice picture, and we try to move my face from here so you can see it. So what I did here was to use a flow, a normal flow. So this slide want to be a recap of this lesson and want to make you thinking. So client goes to CDN, first SSL handshake. CDN goes to the firewall edge. Second, but actually, if you don't publish the IP on the firewall, it's probably on the DMZ or of a load balancer. From there, it's going behind into a pool, behind the load balancer and DMZ in the internal. Later on, you can have a double hop and they take a classical kind of connectivity. So when you see all this stuff, you say, okay, I understood. But you need to put it in perspective because client can go to the CDN, but if a CDN doesn't use a reserve pool to connect to the firewall and actually their network allocation show the IP of the customer that you are trying to poke, you can bypass. So client could bypass your CDN if you don't have obviously a dedicated pool and restriction for accepting that. If you go through, you are already at the load balancer, is already a kind of layer 7. You need to be 100% sure that this load balancer doesn't give error back. And if you give back, it should be translated at CDN. Because if not, you already enumerate which load balancer you have behind. You have a sticky persistence and all other kind of stuff that you can love. And finally reach a server behind. But it's the same. What is the error? Get translated by the load balancer goes. I will have the next lesson talking more about enumeration of infrastructure because it's a big deal in somehow. Everybody consider like it's not relevant, but it is because it's relevant also to cloud. Because it doesn't change the fact that it is a fancy icon in a cloud. It's still the same kind of problem with an added complexity that sometimes the cloud design is a bit more flat. It's more common to find double hop kind of connection into on-prem than actually having a VPC with all network connected in cloud. So you'll find that even cloud does have some infrastructure peculiarity. So let's say that whatever you just did, you reached at layer 7 something. And this diagram itself didn't give you this answer. It didn't tell you if a CDN is having an apply. And actually, isn't UML kind of flow is already zooming in. But this example is to explain you how difficult it is sometimes to get that big picture. So you can hear people say, oh, I'm an architect, I don't care about this stuff, is just implementation. It's not, because you are a security architect. And so you should know which kind of problem you can have. And there are some problem that you can have with CDN. Sometimes they use UI testing, A/B testing, stuff that it can have application routing kind of changes. So we always try to think about routing in terms of classical routing, but you can have application routing. So pay attention to all this stuff, errors, how it's going, ask question, with a logic. You'll find yourself having so many questions and you'll not have probably the customer available to give you all. Trying to come back to your summary, vision, understand north, south, whatever is how the IM fit that picture, and trying to add a zoom in as a double check. Trying to understand, but if you are not an auditor, if you are evaluating the big picture, probably will not check the configuration of the load balancer. And another tricky thing is sometimes you can find also load balancer that later here is the VIP, the external of the load balancer, but you can bypass and go straight into the back tier. So you need to understand this stuff with this diagram. Or now, even if you zoom in, you are smart and trying to keep up, check it out, the SSL and shake, because SSL for me is the key. The first question is, okay, who I'm talking to? Who is having, because obviously if here there is a server and here there is a certificate, it was exported to the load balancer. So it's important security wise too. So just this food for thought, it was to give you an understanding on how it's difficult as infrastructure security consultant to have all data that you need. You need to think more on how pieces of a puzzle are connected. And let's be ready for lesson 2 that will be web stack error response against security, as I already anticipated a bit, but I will zoom in. I hope you'll enjoy the next lesson and you'll subscribe to my channel to be notified when it is available. I'm doing my best to release it once a week if I can, based on my availability, and so don't count on it. Try to subscribe so you get an alarm when you get a new lesson. And remember, you have the slides that I just presented on SlideShare. In the description, you find the link. Thanks a lot for your time. Have a good one. Cheers.